Welcome to Projectile Motion Part 3. We are in discussion with oblique projectile motion. Oblique projectile motion. Recap of the previous two classes. First formula. In oblique projectile motion, x-axis motion is uniform, y-axis motion is non-uniform. First point. Second point, in x-axis or in horizontal direction, speed is u cos theta, and in y direction, initial speed is u sin theta. Initial speed is u sin theta. After time t, uxt, a speed of the body along x-axis remains u cos theta, but a speed along y-axis after time t becomes u sin theta minus gt. Fourth point, in this direction acceleration is 0 and in this direction acceleration is g, that is 10 meter per second square. Fifth point, time of ascent equals to time of descent equals to total time of flight by half, and that equals to u sin theta over z. That equals to uy over z. This is our fifth point. Sixth point, maximum height or greatest height is u square sin square theta over 2z or uy square over 2z. Seventh point, range equals to 2u square sin theta cos theta over z or 2ux uy over z or u square sin 2 theta over z. Eighth point, equation of trajectory. Or locus of the projectile. Is y equals to tan theta x minus gx square over 2u square cos square theta. In another form, y equals to x tan theta into 1 minus x over r, where r is the range. Ninth point, we have discussed condition for maximum range, condition for maximum range, theta equals to 45 degree. Point number 10, when there is maximum range relation between greatest height and range. H equals to u square sin square 45 by 2g, that is u square by 4g, and range is u square sin 2 theta over g, that is u square by g. Means range is 4 times the greatest height. If greatest height is 100, then range is 400. Range is more than height. Point number 10. Point number 11. Relation between range and time of flight. R equals to g cot theta over 2 into t square. R और t का जो ग्राफ है, graph of r and t is like this, parabolic. R and t square, graph is like this. This angle is 45 degree. Point number 12, relation between greatest height and time of flight. H equals to g over 8 into t square, or h is proportional to a square. Same type relation. Graph between h and t, parabolic, and graph between h and t square, straight line. Slope is 1. This angle is 45 degree. Point number 13, relation between range and greatest height. R equals to 4h cot theta. R equals to 4h cot theta. This is the relation. R equals to 4h cot theta. Or this also can be written as R over 4 equals to h over tan theta. Point number 14, when two projectiles are projected from same position with same initial speed, then for achieving same range for achieving same range. Conditions are first is theta 1 equals to theta 2 or theta 1 plus theta 2 equals to 90 degree. Second point, T1 over T2 is tan theta 1. Third point, H1 over H2 is tan square theta 1. Fourth point, R equals to 4 under root H1 H2. Fifth point, R equals to half G T1 T2. Half G T1 T2. R proportional to T1 T2. These are the conditions for gaining same range. Now 15th point, today's class. First concept we are using a projectile projected from the ground. Projectile are at the same height at two different times T1 and T2. Common for both is the height. Initial speed for both is u sin theta. Retardation is z. So taking consideration of y-axis motion, y after time t is u sin theta ut plus half a t square, where time have two values t1 and t2 and value of y after time t is the h. So h equals to u sin theta t minus gt square over 2. Taking LCM or multiplying by 2h equals to 2h equals to 2u sin theta t minus gt square. So gt square plus minus 2u sin theta t plus 2h equals to 0. t1 and t2 दो value. This is like a standard equation ax square plus bx plus c equals to 0. So solution is and t1 t2 like alpha beta. In quadratic equation we have some property alpha plus beta minus b over a. So t1 plus t2 equals to minus b. B is minus 2u sin theta over a is z. So t1 plus t2 equals to 2u sin theta over z. This is our time of flight. So t1 plus t2 equals to time of flight. This is our first condition. We have another property of quadratic equation alpha into beta Ca. Here alpha is t1, beta is t2 and c is what? C is 2h. C is 2h. A is z. So cy means 2h over z. 2h over z. And h is what? H is half z t1 t2. So if after time t1 and t2 body or projectile lying on the same height, then conditions are t1 plus t2 is the time of flight, and second condition h is half z t1 and t2, half z t1 and t2. Suppose in the oblique projectile motion, we have to calculate displacement and distance covered by projectile when it again comes on earth surface. Answer is simple. Distance equals to displacement equals to, what is displacement? Vertical displacement 0, horizontal displacement equals to range. So total displacement equals to range. What is distance? How we can calculate distance? We have formula. Distance equals to integral a speed dt, v dt, 0 to t. This is our distance. So what is v after time t? V equals to u cos theta I u sin theta minus gt along z. This is our speed velocity. What is its magnitude after time t? That equals to under root u cos theta square plus u sin theta minus gt cos square. So distance covered by the projectile is integral under root u square cos square theta plus u sin theta minus gt square dt. Zero to t under root u square cos square theta. Breaking this part, a minus b का whole square u square sin square theta plus z square t square minus 2u z t sin theta. So that equals to 0 to t u square common sin square plus cos square 1. Therefore u square plus z square t square minus 2uz sin theta t dt. After integration we can calculate the range. How we can calculate? We have to convert it in the form of under root a square plus x square, and we all know under root a square plus x square dx formula. Next, suppose we have to calculate distance and displacement covered by projectile. Distance and displacement covered by projectile till body reaches its greatest height. Greatest height point. What is our displacement? This length is our displacement, total displacement, and this is our distance, and this length is displacement. How we can calculate displacement? This is r by 2 and this is s. So displacement is under root r by 2 का whole square plus h square. By putting value r and h we can calculate displacement. How we can calculate distance? Same process. Distance equals to integral 0 to t over 2 integral v dt. We can calculate distance and displacement. Suppose we have to talk about momentum of the projectile. Momentum of projectile. Momentum maximum points. Suppose we have to choose momentum maximum points. Which points are maximum momentum points? Answer is AB, because the speed at A and B are maximum at AB. Minimum momentum point. Minimum momentum points is C, where horizontal component only exists. Calculate average velocity of projectile in a time of flight. Average velocity is total displacement by time. Total displacement in a time of flight is R. So R over T is the average velocity. What is R? 2. R is 2 U square sin theta cos theta over Z. What is T? T is 2U sin theta over Z. So G gets cancelled, 2 gets cancelled, 1 U gets cancelled, sin theta. So average velocity is the U cos theta. X component velocity is the average velocity. X component velocity is the average velocity. X component average velocity. Suppose we have to calculate average velocity for T over 2, half time of flight, or till body gains greatest height. T over 2 के लिए एवरेज वेलोसिटी क्या होगी? The average velocity is total displacement over time. So total displacement is under root r by 2 का square plus h square over t over 2. So 2 by t under root r by 2 का square plus h square. This is the required average velocity. After solving, time of flight is 2u sin theta over z. What is r by 2? R by 2 is u square sin theta cos theta by z का whole square plus what is h? u square sin square theta over 2z का whole square. So z gets cancelled, 2 gets cancelled, and u का power 4 common, u square, u gets cancelled. So u over sin theta under root sin theta cos theta square plus sin square theta का whole square. So u under root sin theta cos theta का whole square divided by sin square theta plus साइन स्क्वायर थीटा का होल स्क्वायर डिवाइडेड बाय साइन स्क्वायर थीटा. 1 sin square theta gets cancelled. Sin square theta u sin square plus cos square is 1, therefore u. So in a t/2 average velocity is u, that is r initial speed of projection. Initial speed of projection. Now we talk about kinetic energy. Kinetic energy, potential energy, and total energy of projectile. Kinetic energy is represented by K, potential energy U, total energy E. Kinetic energy K, potential energy U, total energy E. Suppose in oblique projectile motion, trajectory is like this. We know here speed is u sin theta, and in this direction speed is u cos theta. Here speed is only u cos theta. Here speed is u cos theta and u sin theta. After time t speed is u cos theta और यह है u sin theta minus gt. So kinetic energy maximum A, B, C, D. Kinetic energy maximum points A and D. Kinetic energy minimum points C. Potential energy, kinetic energy maximum value half m and initial speed is u square. Kinetic energy minimum equals to half m u cos theta square. Dividing, we can get a relation. Kinetic energy maxima divided by kinetic energy minimum. That comes out to be half gets cancelled, m gets cancelled, u square 1 over cos square theta. So kinetic energy maxima, kinetic energy minima equals to kinetic energy maxima cos square theta. Kinetic energy minima equals to kinetic energy maxima cos square theta. Potential energy, we all know about gravitation or gravity field is a conservative field. If projectile lies on greatest height, it means potential energy is large. Potential energy is large. Therefore, in this trajectory, if this point is A, this point is B, this point is C, this point is D, potential energy maximum point is D, potential energy minimum point is AB. And what about total energy? Total energy E of the projectile, due to energy conservation, all points have equal total energy. So therefore, total energy at A equals to total energy at B equals to total energy at C equals to total energy at D. Kinetic energy, potential energy and total energy of the projectile. Now we talk about angular momentum. Angular momentum of projectile. Angular momentum L of the projectile. Suppose this one is our trajectory and this point is A, this point is B, this point is C. We have to calculate in first point angular momentum of projectile when it is at point B with respect to point of projection. What is angular momentum? We can solve this. What is angular momentum? Angular momentum is R cross P. Or R multiply momentum perpendicular to R. So here is our reference point and here is the projectile and this one is our R. So in this direction momentum is mu sin theta. We all know u sin theta speed in this direction. So angular momentum and R is nothing but the range. So angular momentum of B with respect to A is R multiply mu sin theta and R is u square 2u square sin theta cos theta over z multiply mu sin theta. Therefore, angular momentum of B with respect to point A is 2mu का power 3 sin square theta cos theta over z. So angular momentum depends on u ka power 3. u ka power 3. Now in the next point, suppose we have to calculate this one is our trajectory, and here is the projectile. We all know if projectile have mass m, a speed is only u cos theta, and this is our reference point. So what will be the angular momentum? A, B, and this is our C point. Angular momentum of C with respect to A. This we have to calculate. So here direction of momentum is this, and perpendicular to the momentum is this length. So angular momentum of C with respect to A is momentum multiply distance perpendicular to momentum. Momentum is mu cos theta and perpendicular distance is h. So mu cos theta, and what is maximum height? U square sin square theta over 2c. That equals to mu का power 3 sin square theta cos theta over 2c. So we have result. Angular momentum of B with respect to A is 2mu cube sin square theta cos theta over z, and angular momentum of C with respect to A is mu cube sin square theta cos theta over 2c. So angular momentum of B with respect to A is larger than angular momentum of C with respect to A. Angular momentum of B with respect to A is 4 times, and C with respect to A 4 times. 4 times is the angular momentum. 4 times is the angular momentum. In the next part, we have to calculate torque acting on a projectile. Torque acting on a projectile about any point. This point we have to discuss. What is torque? Torque is R cross F. Torque is R cross F. Torque is R cross F. So suppose this one is the trajectory of the projectile at any time t. Suppose projectile is at this point. Force acting only is gravity force mg. Suppose we have to calculate torque about point A, initial point or point of projection. What is the torque? Torque is simply this distance multiply mg. Torque at any time is R multiply mg. Torque is R multiply mg. Suppose in an example we have to calculate torque on projectile when it reaches the ground with respect to projection point. What is the torque? Here is the projectile. Force acting is mg downward, and this distance is r. So torque is mg multiply r. Torque is mg. mg r is 2u square sin theta cos theta over z. So torque is 2mg gets cancelled. 2mu square sin theta cos theta. Torque is 2mu square sin theta cos theta. Torque is proportional to u square. In the next point, if this one is our trajectory, body is at this point, this is our reference point, we have to calculate torque of C about point A. mg acting in this direction and perpendicular distance is r by 2. So torque comes out to be mg r by 2. Simply mu square sin theta cos theta. Sin theta cos theta. Torque of B about A is 2 times torque of C about A, and both torque is proportional to u square. So in this way we can calculate torque. Now we have to discuss radius of curvature. Radius of curvature of projectile at any instant during its motion. During its motion. During its motion. What is the radius of curvature? We all know in circular motion, in circular path, if body is moving on circular path, there must be a force that is acting toward the center. Means centripetal force is mv square over r. Here r is the radius of curvature. So if we have to calculate r, then r must be mv square over f. F is the force acting towards center. In this way we can calculate r. In projectile motion, any curve path or its a portion can be treated can be treated as a part of circular of different radii. Suppose in a trajectory is a parabolic one. Suppose here we have to show center and radius of the circular path. This path may be a part of this circle. This one is a speed u, and this may be our center. Here also a speed is u cos theta, and this part may be treated as a part of circular. So this one is the radius and this one is the center. So we have to calculate different radii r dash. In an example, find radius of curvature of projectile in oblique projectile motion when it is at greatest height. Greatest height point is like this. Suppose this one is our circular path and this is the r. mg acting in this direction. Here mg is the centripetal. A speed is u cos theta. So mg equals to m v square over r. Gets cancelled. So r is u square cos square theta over c. This is our radius of curvature at greatest height. In the next example, find radius of curvature when body is at the projection point. Projection point पे ही रेडियस ऑफ कर्वेचर कैलकुलेट करनी है. This one is our trajectory. The speed is u. This angle is theta, angle of projection. Mg in this direction. So taking perpendicular to the tangent, this is theta 90 minus theta, then this one is theta. So component of mg toward the center is mg cos theta. Suppose this radius is r, so mg cos theta is the centripetal and that equals to mu square over r. Gets cancelled. So r is u square over g cos theta. So r is u square over g cos theta. In the previous one, this is u square cos square theta over z. In the next example, find radius of curvature when angle made by trajectory with horizontal becomes half of the angle of projection. So according to the question, this one is our trajectory. If this angle is theta, angle of projection, then there must be a point where this angle is theta by 2. What is a speed here? Suppose a speed is v, and we all know horizontal component never changes. Therefore, v cos theta by 2, here speed is u cos theta. So v is u cos theta over cos theta by 2. This one is unknown speed. Mg, circle is like this, in this direction, radius is r, and mg in this direction acting. This angle is also theta by 2. So in this direction, mg cos theta by 2 component exists. We all know centripetal force is mv square by r. Same formula using. Here f is mg cos theta by 2. mg cos theta by 2 is m v square over r. And what is v? v is u cos theta over cos theta by 2. So mg cos theta by 2 equals to m, and v is u cos theta divided by cos theta by 2 का square divided by r. M gets cancelled. Therefore, r comes out to be u square cos square theta divided by g cos q theta by 2. This one is the radius of curvature. So conclusion is r for greatest height is u square cos square theta over z. U square cos square theta over z. Second point, r for projection point is u square over z cos theta. And third one, or this may be written as r at theta angle. R at theta by 2 angle is u square cos square theta divided by g cos q theta by 2. U square cos square theta g cos q theta by 2. So this is a general 3 points to remember. In next class, projectile motion part 4, we will discuss about oblique projectile motion from a moving body. Moving body may have constant speed or constant acceleration. We will discuss this part in the next class. Thank you.